Hi guys, I hope you are all doing well. So let's continue with our series of questions on JEE mains from April 2024. And today's question that we are taking up is from the topic of definite integrals. Let's see the question and understand how to solve that further. So the question tells us to find the integral of a value where the limits are from 1 over 4 to 3 over 4 and the expression that is given to us is cos of 2 cot inverse root of 1 minus x divided by 1 plus x. That is the entire expression given to us and the question is asking us to figure out the value for this. And if I talk about the answer choices I have here, the options are minus half, minus 1/4. The third option we have is 1/4 and the fourth option we have is half. So we need to figure out which one of the answer choices is the correct answer for the question that is given to us here. Let's figure out how to solve this question further. Before starting off with the solution for this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well because it also motivates me to put up better content and try to make the solutions as easy as possible so you understand them in a better way. Let's see how to solve this question further. So once I have cot inverse of root of 1 minus x and divided by 1 plus x. So if I first try to solve for that, let's solve for that. So cot inverse when I have with 1 minus x and 1 plus x, I know one idea that using the trigonometry formula, which is 1 minus cos 2 theta, I know it is 2 sine square theta and 1 plus cos 2 theta, I know it is 2 cos square theta. So if I have both of them divided, I can get tan here for this, right? So first let's try to solve this part only of the entire expression. So we are just going to put here x as cos 2 theta. So if I'm putting this expression here cos 2 theta, I get root of 1 minus cos 2 theta divided by 1 plus cos 2 theta. So if I further try to simplify, I get 1 minus cos 2 theta, which is 2 sine square theta, 1 plus cos 2 theta, which is 2 cos square theta. 2 and 2 gets cancelled, you get square root of sine divided by cos, which is tan square theta, and square root of tan square theta, which is nothing but tan. So I have this tan theta for the entire expression. Now I have to find the integral. So let's go for that. So I have to find the integral for the limits from 1 over 4 to 3 over 4 and cos of 2 cot inverse of root of 1 minus x divided by root 1 plus x, which already got me tan theta. So I got tan theta. Now once I know tan theta, I have outside cot inverse to make this also in terms of cot first. Let's do that. So I know if I want to make tan in terms of cot, I can use my idea of complementary angles. So I know tan theta I can write as cot of 90 minus theta. So if I write that using it, so I get this is limits from 1 over 4 to 3 over 4. Now, because I have made my entire expression in terms of theta instead of x, my limits would also change. So we cannot have 1 over 4 and 3 over 4. So 1 over 4 and 3 over 4, when I have for x, for theta, the limits would change, but we don't need to find it. We'll further then again resubstitute my entire equation in terms of x. So we'll have the same limits. So let's keep for 1 over 4 the limit is alpha and for 3 over 4 the limit is beta. So basically my limits won't be 1 over 4 to 3 over 4, it would become alpha to beta. So I get this as alpha to beta cos of 2 cot inverse of tan theta I can write as cot of 90 minus theta. And cot inverse of cot will basically cancel this cot and you will be just left with 2 multiplied with 90 minus theta. So limits become alpha to beta cos of 2 90 minus theta. So you get from here limits turning to become alpha to beta cos of 2 into 90, which is pi minus 2 theta, and cos of 180 minus 2 theta. I know whenever it is pi minus something, the trigonometric ratio remains same as it is, but pi minus something would make it basically in second quadrant. And in second quadrant, if I check for cos, I know all silver teacups So only sine and cosec are positive, cos is negative in the second quadrant. So it will give you minus cos of 2 theta. And one more thing we have to take care and consider here is that when you have here dx with us, we also have to write entire thing in terms of d theta. So since I have put x as cos 2 theta, so in that case, if I differentiate it, I get dx as minus sine 2 theta into 2 d theta. So I have to substitute that also when I'm writing my integral. So I have minus 2 sine 2 theta d theta as well everywhere. So minus 2 sine 2 theta d theta should be there with every expression. So at the end also I will have here 2, sorry, minus 2 sine 2 theta d theta. So here also it would be there. So we missed that step, but let's continue doing it. So from here, once I have this, I get this as alpha to beta 2, because negative into negative makes it positive, sine 2 theta cos 2 theta d theta. So once I have that, let's further write it. So it is basically in the form 2 sine 2 theta cos 2 theta, which I know it's an expansion. If I have sine 2 theta, it basically becomes 2 sine theta cos theta. Just instead of theta here, I have 2 theta. So my answer, or this expression, would also become sine of 4 theta. So my limits would be alpha to beta, finding the integral of sine 4 theta d theta. And we know integral of sine theta is minus cos theta, so it will become minus cos 4 theta. And dividing by the coefficient of theta, which is 4, limits going from alpha to beta. So I have basically minus 4, 1 over 4 and cos 4 theta, limits going from alpha to beta. And now once I have cos 4 theta, if I use my idea of double angles again, I know cos 2 theta is 2 cos square theta minus 1. So in that case, if I have cos 4 theta, I can write that as 2 cos square 2 theta minus 1. So we have this expression. Let's further write it. So you have minus 1 over 4, 2 cos square 2 theta minus 1. Limits going from alpha to beta. Now once I have cos 4 theta written as 2 cos square theta 2 theta minus 1, and we know we have already put cos 2 theta as x. So if I'm resubstituting, I'll get my limits of x back. So minus 1 over 4, I get 2x squared minus 1. Alpha and beta will now change to 1 over 4 and 3 over 4. So let's just solve it and evaluate and get the answer for this. So minus 1 over 4, 2 times 3 over 4 square, which is 9 over 16 minus 1, minus 2 times 1 over 4 square, so 1 over 16 minus 1. So I get minus 1 over 4, 18 over 16, minus 1, minus 2 over 16, plus 1. So minus 1 and plus 1 goes away. 18 minus 2 gives you 16 over 16. So minus 1/4 into 1, which is minus 1. So I get the answer to this question. And if you see the answer choice that matches here with the question, it is option B. So B becomes the correct answer choice for the question that is asked to us to find the integral of this entire expression with the limits from 1 over 4 to 3 over 4. The correct answer choice for this becomes option B. I hope you have understood how to solve this type of questions, which deals with the ideas of using the substitution idea. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains. So if you're enjoying these videos that we are doing on everyday basis, please do like the videos and do comment and share this with your friends also who are involved in the preparation of these questions on JEE. I'll see you again tomorrow. Thank you.